All right, so in this video, we are going to evaluate the following integral. Now, we can evaluate this integral using trig substitution. And let's say that x equals 2 secant theta. Therefore, dx is just the derivative of this. Well, that's going to be 2 secant theta tangent theta, d theta. So we're going to replace x with 2 secant theta and dx with 2 secant theta tangent theta d theta. So then, what does the square root become? Well, what you're often told to do is to draw a right triangle. And we're going to say that theta is this angle right here. Now, because x equals 2 secant theta, that implies that secant theta is x over 2. And in our right triangle, secant theta is hypotenuse over adjacent. So that's going to be x over 2. Therefore, by the Pythagorean theorem, this side length must be the square root of x squared minus 4. Therefore, the tangent of theta is the square root of x squared minus 4 over 2. Multiplying 2 to the other side, you get this. Therefore, we are going to replace the square root of x squared minus 4 with 2 tangent theta. So overall, we're going to rewrite this integral in terms of theta using these three things. So now we have our integral in terms of theta. Notice that the 2 secant thetas cancel out. So overall, we're left with 2 tangent squared theta d theta. We can pull the 2 to the outside of the integral. So this is the integral that we're evaluating at this point. Now, to evaluate an integral like this, we could use the trig identity for tangent squared theta, right? Tangent squared theta is equal to secant squared theta minus 1. And now we can evaluate this integral directly. We know that the integral of secant squared is tangent. The integral of 1 is theta. Now at this point, we can distribute the 2 across. And now what we're going to do is we are going to re-express this back in terms of x. Now we know that 2 tangent theta is the square root of x squared minus 4. So then what's theta going to be? Well, we could go back to what we have up here and solve for theta. Theta is just the arcsecant of x over 2. As a result, we can just replace theta with arcsecant of x over 2. And so this is our final answer. But is it correct? No. It is true that this is the answer if x is positive. But if x is negative, then you have to put an absolute value here. That's odd. Why would there have to be an absolute value here? So this is actually the right answer. And again, why do we have to have an absolute value here? Where would that absolute value come from? Clearly, this absolute value didn't show up anywhere in our work. So, was there something wrong with what we did? And really, if this is the right answer, then we should be able to take the derivative of this thing and get exactly what we have back in the integrand. And if we take the derivative of this thing, it will not be identical to what we have in the integrand. And it turns out that's true. So this has to be the answer, right? This is the answer for all possible values of x we could have here. So in the next video, we are going to evaluate this integral the right way. Because clearly there's something wrong with what we did here. But yeah. So yeah, that's pretty much it for this video.